Hi guys, welcome back. Um, so I thought for this video, what I would do is go over from AMC 10A 2021 fall, go over numbers 21 and 22. Because for those, I was able to come up with my own solutions. I don't think I'll go over the last three because, to be honest, I needed help with those ones. And I don't want to just present somebody else's solution. So unless, if you'd like me to try to explain in some other way if possible. But so I don't think I'll go over the last three. But anyway, let's do 21 and 22. I'm hoping this will be a little bit shorter video. 21 is actually really not that hard, but I'll be honest, I actually did not get it right at first. I made a kind of a silly mistake. Says each of the 20 balls is tossed independently and at random into one of the 5 bins. Let P be the probability that some bin ends up with 3 balls, another with 5 balls, and the other with 4 balls each. Let Q be the probability that every bin ends up with 4 balls. What is P over Q? So what I did when I initially solved this problem, I calculated the different ways in which you could get the balls to be so that I could go 3 in one, 5 in another, and then 4 in the others, right? Which basically it turns out that there are 20 ways for that to happen because so how can we think about that? If we assume the balls to be indistinguishable, right, then essentially we will have like, we have one bin will contain 5, one bin will contain 3, and the other 3 will contain 4, and we just want to see how many different ways to arrange those numbers. Well, if you think about it, we could do, well, if, we can think about it as being like 5 different objects. So we can say that there'd be 5 factorial ways to arrange them, but you would have to divide by 3 factorial because the 3 4s are identical. So you can just rearrange those 4s and they would just always be the same thing. So we're just sort of dividing out the repeats, right? So 5 factorial divided by 3 factorial is 5 times 4, which is 20. So there are 20 ways for it to happen, as opposed to each containing 4 balls is really just one, which is that each contains 4 balls. So my original answer was 20, but looking back, like, that doesn't make sense because we have to also consider the likelihood of these 2 events occurring. So in other words, like how much more likely is it for you to get that 3 5 4 4 4 arrangement as opposed to a 4 4 4 4 4 arrangement, right? Well, we can sort of look at the probabilities and say, okay, well, if we think about it, so we're looking at the probability of 5 3 4 4 4 versus 4 4 4 4 4, right? And if we think about it, these probabilities are just going to cancel out, right? So we can really just look at these situations. Right? Because even if we take into account the arrangements, they're still going to cancel out because they're the same situation. So we're really only looking at the different cases, which is a 5 and a 3 versus a 4 and a 4, right? Well, now think about it. If assuming that we're given that these situations already occurred, the 4 4 4 and the 4 4 4, right? Well, that means 12 balls have already been placed because, right, 4 4 4, that adds up to 12. So there's only 8 balls left, and we want the probability that 5 will go into one and 3 will go into the other. Well, if we think about it, like, how many ways can that happen? Well, if there's 8 balls remaining and we want 5 of them to go into one bin, it's going to be 8 choose 5. And then the last 3 will all have to be going into this bin, right? And then down here, we would have 8 choose 4, and then 4 choose 4. Sorry, I shouldn't have put the this thing, right? So it's 8 choose 5 times 3 choose 3 over 8 choose 4 times 4 choose 4. But 3 choose 3 and 4 choose 4 are both 1, so we can cancel those out, right? So we're really just looking at 8 choose 5 divided by 8 choose 4. Now 8 choose 5 is 8 times 7 times 6 times 5 times 4 over 5 times 4 times 3 times 2 times 1. 8 choose 4 is 8, 7, 6, 5 over 4, 3, 2, 1. And now if we think about it, we can cancel some things out. We can cancel out 8, 7, 6, 5 with 8, 7, 6, 5, right? And we can also cancel 4, 3, 2, 1 with 4, 3, 2, 1 because that'll get flipped and then they'll just cancel out. So really all we're left with is 4 over 5. So what that means is that it's 4/5 as likely to get the situation where the balls go 5, 3, 4, 4, 4 than all fours. Right? It's 4/5 as likely for that to occur. But notice how we also determined there are 20 more ways that it can occur as opposed to the 4, 4, 4 situation, right? There's 20 different ways, assuming the balls to be indistinguishable, there's 20 different ways for it to happen, but it's also 4/5 as likely. So because it's 4/5 as likely and 20 more ways, that means it's overall 16 times more likely to occur. Right. So, right. That, and what I forgot to take into account was the likelihood. You can't just count the possibilities because you have to also consider that one is more or less likely to occur than the other. So that's where probability gets a little tricky. But so the answer is E, 16. Overall, not a crazy hard problem, but almost deceptively easy to a point where you might make the same mistake that I made. Probability can be very tricky like that, so you just have to be careful with it. All right, let's look at 22. 22 is going to be very hard for me to explain. Anything with 3D geometry is super hard to explain. Hopefully I'm going to really try my best with this. So they tell us inside a circular cone, right circular cone with base radius 5 and height 12 are 3 congruent spheres with radius r. Each sphere is tangent to the other 2 spheres and also tangent to the base and side of the cone. What is r? So first thing we want to do is sort of draw the situation, which again is not going to be super easy, but I'll do my best. So we have these 3 spheres, sort of, I don't know, you have to imagine that they're all touching the base while also tangent to a side of the cone, right? So they're kind of like wedged into sort of the bottom of the cone, right? We know that the base radius of the cone is 5. Whoops. We know that the base radius of the cone is 5. And we know, so let's say that's like the center, right? And we know the height of the cone is 12, right? We want to find the radius of the spheres. So how I approached this was I sort of imagined a cross section of the cone where one of the spheres is tangent to the slant edge of the cone. So let's say this is sort of like the slant edge of the cone. Here's the center of the cone, right? So we're gonna have a right triangle. One of the spheres is gonna be here, right? And it's gonna kind of go like this, right? It's gonna be contained in there. So, right, and it's gonna be tangent at that point, right? So what we know is that if we sort of draw like to the center of the sphere, this is R, right? And we know that these 2 angles are both 90 degrees, right? because anywhere a circle is, how do I say it? A tangent is always perpendicular to a radius at the point of tangency, right? Now, we know that this height is 12, and we know that this is 5, right? So what we could do is we could think about, like, how much is this angle here, right? I'm going to label this angle here alpha, right? But we know that alpha is what? Inverse tangent 12 over 5, right? Alpha would be inverse tangent 12 over 5 because, right, the height opposite is 12 and adjacent is 5, right? Now, if I look at this quadrilateral here, right, I have two right angles, which means that this angle and this angle have to add up to 180, or pi, right? So what that means is that this angle over here, right, this angle over here, right, would be pi minus alpha. Let me, whoa, sorry about that. Let me draw that a little bit better. So that's pi minus alpha, right? Okay, or pi minus inverse tangent 12 over 5, right? Now, what I want to do is I want to find the sort of horizontal distance here, right? And I also want to find this little vertical distance, which actually maybe I'll do that in a different color. So I'm going to do that in pink. So here to here, I also want to find this height here, right? Okay, so and this angle would be 90 degrees. Right, this distance is r. Now, what do I know? Well, if this angle here is pi minus alpha, then that means that this angle in here, right, this little angle here, must be alpha. Right? I know that that angle there must be alpha. Right? Which, if you think about it, that means that this little triangle here, this little right triangle here, is similar to the large triangle. Right? It's similar to the large triangle because it has a 90-degree angle and an angle alpha. 90-degree angle and angle alpha. So if I kind of draw the two triangles, right? If I sort of separate them, right, where this is 5 and this is 12. So this is the big triangle, right? That's this triangle. And then I draw basically this triangle over here, right, where this distance is r. And I know that these angles are both equal to each other, right? And I know these angles are both equal. So I know the triangles are similar. Now, you should know that when you have 5, 12, the hypotenuse has to be 13. So if we think about it, what's sort of the ratio? Well, the ratio is 13 to r, right? 13 to r ratio. So what does that mean? That means to get to the second triangle, I'm multiplying by r over 13. So then what does that mean? That means that this distance over here is 12r over 13. And this distance down here is 5r over 13. Remember, I had to sort of tilt the triangle to draw it. So this distance here is 5r over 13. And this distance here is 12r over 13, right? Because remember, it's like tilted 90 degrees. So, well, what does that tell me? Well, let's start putting some pieces together. Well, think about it. So if this distance here, let me use red. If this distance here is r, right? And this distance here is 5r over 13. What's r plus 5r over 13? 13r over 13 plus 5r over 13 is going to give me 18r over 13, right? But what does that mean about this height here, this distance, right? From here to here, right? Well, if the whole height of the triangle is 12, right? And here to here is 18r over 13, then that means that this distance must be 12 minus 18r over 13. Right? Here to here would be 12 minus 18r over 13. Okay? Now, if I could just find this green horizontal distance, right? I have a piece of it, right? I know that this piece is 12r over 13. I just need this piece. I'll do it in like a dark red. I just need this piece here, right? Which if I think about it, that's the distance from you know, it's hard to explain, but like imagine we're looking at sort of an overhead view of the three spheres, right? It's going to be the distance from the center of one of the circles. Whoops, let me draw this a little bit better because it needs to be because so if I draw the three circles, right? There's like this little sort of space in the middle, right? And I need to find the distance that goes from the center of one of the spheres to this center here, right? This sort of little center in the middle here. Now, you might think, how the heck can I find that? Well, remember, if I draw from each of the three centers, here to here, here to here, this is R, 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 R. So this is an equilateral triangle, right? And really what I'm trying to find is the distance from a vertex to the center of the equilateral triangle. But one thing you can know when you have an equilateral triangle, right? If you draw an altitude, right, which we can calculate that altitude, right? And then we find another altitude, right? And we find that intersection point, right? That intersection point would be the center of the triangle, right? And it turns out that that always separates the altitude into a 2 to 1 ratio. It always splits up the altitude into a 2 to 1 ratio. So if I can find the height of the triangle, all I have to do is multiply it by 2/3, and that will give me the distance from the vertex to the center, right? So I need to find the height of the triangle, the altitude, and multiply it by 2/3. So let's see, how can I find the height? Well, if this distance is 2r, right? This distance is r if I draw the altitude, right? So I have basically r, 2r. This angle's 60 degrees. This angle's 30 degrees. So if you know your 30, 60, 90 right triangle, you know that all you do is take this side and multiply it by root 3. So this height is r root 3, right? This height here is r root 3. Okay, but remember, I only want 2/3 of it so that I can get the distance from here to here, right? No, oh, sorry, that's too far. From here to here, right, is going to be 2/3 of that height. So what that means is this distance here is 2/3 r root 3. Okay, so that distance there is 2/3 r root 3. So let me write that. Let me write it in the dark red. So that's 2/3 r root 3. So what does that mean? That means that this whole green line here, right? This green line here is 12 13ths r plus 2/3 r root 3. Which if I make a common denominator becomes 36r plus 26r root 3 all over 39, right? That would be what I'd get if I did the common denominator. So now what I'm going to do is I'm going to set up two similar triangles because I know that this triangle here, right, is similar to the big triangle, right? So what I'm going to do is I'm going to say, okay, the red distance. So I'm going to erase to make some room for myself. This is where we get into some really complicated algebra. So the red distance, right, is 12 minus 18/13 r over this, the green distance, right? Or now I did it in red, but so 36r plus 26r root 3 over 39 equals 12, the whole height, right, divided by 5, the base, right, equals 12 over 5. And now I just need to solve this, right? So again, I'm going to erase to make myself some room. And this just honestly becomes some very annoying algebra. Not fun. Took me a while to get, I'll be honest with you. I'll show you some of the steps I did, but I'm not going to show every single step because it's honestly a little bit too much. But basically what I did was I started by dividing the whole numerator by 6. So dividing this, and this each by 6, right? So that gives me 2 minus 3/13 r over 36r plus 26r root 3 over 39 equals 2 over 5, right? And then what I did was on the left side, I multiplied everything by 39 in order to get rid of the smaller fractions. So what that gave me is it gave me this. It gave me 78. Whoops. Let me draw that better. I don't have a stylus. I'm using my finger. That's why it's not great. 78 minus 9r over r times 36 plus 26 root 3 equals 2 over 5, right? And then I cross multiplied. Should move this out of the way. So then I cross multiplied, which gave me 390 minus 45r equals 72r, that's an r, plus 52r root 3, which gave me r equals 390 over 117 plus 52 root 3. And then honestly, what you have to do from this point is just do a simplification, which is very tedious, very annoying. You know, I'm sure you guys have learned about how to do the conjugate, right? You're just going to deal with really messy, annoying numbers. I'm not going to lie. But ultimately, by doing that simplification, you end up with r equals 90 minus 40 root 3 over 11, which is choice B. So you get B as your answer. Yeah, so honestly, not a super fun, like the problem itself is fun, but the algebra you have to do at the end is just honestly a little bit too much. Again, I've looked up much better solutions than mine, but I don't want to steal other people's solutions. I want to show how I did it, even if it's messy. And then, you know, maybe have a discussion or whatever about how maybe you can tell me how you did it and if it was better. So yeah. All right. So anyway, I think I'm going to end it here. I'm only going to do these 2. Like I said, I'm not going to do the last 3 because I needed help with the last 3. So but yeah, I'm going to figure out what I want to do. I might go over the 10B. Honestly, what would really help me is if you guys could give me some suggestions of what you'd like me to do. You know, do you like sort of me going over the AMC 10? Would you like me to look at AMC 12? You know, I like just sort of going over AMC 10 problems, but you know, I'm open to take suggestions of different things that I can do. So anyway, okay, so I'll see you on the next video. And that will be that. Have a good one.